Alright, so the next exercise is having a curve like that. We'll be starting at 5 volts and ending at 10 volts. So we are clipping 0 to 5 volts. Alright, so many times you may have different channels of analog output cards and you want to use those voltage range of 0 to 10 volt at different areas. So you can use 5 to 10 volt this way for one drive, and you can use 0 to 5 volt for another drive. Alright, so you can use two drives with one analog card. So this is one of the example how we can do 5 volts to 10 volts. If you recall, we have seen similar one like that where we were using 0 to 5 volts. So rest of the voltage can be used for another drive as well. So to clip this voltage, bias voltage range, what is that? 5 volts divided by full range 10 multiplied by 100. What is this? Oops, not 1000, it's 100. This is 50%. So the biasing is 50% adjustments. Let's put that in parameter 48. So 48, that should be 50%. Alright, that goes to almost there. Yeah, it's 50%. Now bias polarity is 1 because this is a biasing in this axis. Potentiometer frequency gain, it says full voltage range, again 10 volt. Effective voltage, effective is 5 volts, which is being used in the curve. Multiply by 100, accounts to 100%. So the gain is 200%, biasing is 50%, which will give me this results. So gain, I'm going to 50. Gain will be 200% here. So let me just quickly go to 200%. Pressing enter. Perfect. Now frequency is 50 Hertz at 10 volts. If I move to 5 volts, 0 Hertz, almost 0, some noise is there. So beyond that, at 7.5 volt, it will give 25 Hertz. And at 10 volts, you may get 50 Hertz. So that's the curve we have achieved from 5 volt to 10 volt, 0 Hertz to 50 Hertz. So that was one of the example of biasing. Alright. Next we will see biasing in this curve. This is very interesting again. Alright. So thank you for now.